I'm Jeff Helms. I'm the Global Automotive Manager for Celanese, and I deal with the transportation side of the business. Celanese engineered materials is really focused on engineering plastics for end items like automotive, consumer, medical, industrial. Everyone's looking to take mass out of vehicles. Part of that's being driven by CAFE standards. The other is being driven by how do I make a vehicle perform better, right? With the same kind of powertrain, and then I need to drop some mass out. Mass is a big driver. Celanese has a fairly broad portfolio. When you think about weight, you think about metal substitution. How do I take something that was in steel originally, or even aluminum, and drive that weight down? And we do that with our long fiber technology, which is usually either a glass fiber with a polypropylene matrix or a nylon matrix holding it together, or what we're starting to see a lot more of is carbon fiber reinforced materials. Right? Because that's really taking a lot of mass out, providing a lot more stiffness, but there's a cost trade-off. So you have to think about that. Celanese portfolios, we think about 150 different applications across a vehicle. And any given vehicle may have 20, 25, 30. The number of prototypes built today is probably 10% of what it was built 10 years ago. So frankly, engineering doesn't have prototypes to test, right? Or they've got to do a lot better job of making sure they're testing everything on the prototypes they do have. And if you miss one of those, you're in trouble. I think that's really pushed people to everywhere from the OEM down through the value chain is to use those analytical tools up front. Validate the static performance, the dynamic performance analytically, eliminate the prototype step if possible, and go straight into production tooling. Because ultimately you want to go from a CAD model to a physical production tool, shoot parts, put them in a vehicle, run them on durability, and be done. Celanese, our engineered materials, is routinely exchanging CAD files with manufacturers so that we can look at the design early and make recommendations before they go into any kind of tooling. Mold flow simulations, warpage analysis, just looking at flow behavior in general for appearance kinds of parts. All of that's being done analytically before we get to tools. You're always trying to control fiber orientation based on what the analytical evaluation of the load path is, right? So you're doing the analytics to understand where the load path's going and then putting your gates in a position to make sure that fiber orientation is in the right location. You've got durability requirements you have to fulfill. Some of those are long-term. The key is how do you combine those parts and then validate analytically the performance of that solution before you go off and cut tools. Lightweighting is going to happen. Not everyone's going to do it the same way, but the overall dynamics, the overall industry drivers, the regulations affect everyone equally. So we're seeing a lot of that going on. Cost will always be there. I've heard this thing in the industry, weight is the new cost. No, now weight is more important than it was, and cost is still as important as it was, right? So now you're hearing more about weight and cost and not just cost. If you want to do something in 2021, you got to kind of start working on it today and validate it into, let's say, a low volume vehicle line, and then once you've got it validated, extend it to a high volume runner.